Good evening, ladies and gentlemen. I hope you have enjoyed your experience with us today so far at BRES. I would like to take this opportunity to bring the conversation back home to Brunel University, London, and showcase the range of work being done in robotics and AI from student societies all the way up to very advanced research initiatives.
Good afternoon. My name is Tatiana Kolganova, and I'm director of the Center for AI, Social and Digital Innovation. I have more than 25 years experience working in AI, design, and hardware.
Hi there. Some of you might recognize me from earlier on at the welcome introduction part. My name's Ben Mounier. I'm the BRES founder and current chairman. I also did my undergraduate degree in electronic and electrical engineering here at Brunel University. And I'm currently in my final year of my PhD researching 5G networks for indoor localization in VR applications.
Awesome. And my name's Ed Schroeder. I'm the BRES Vice Chairman, aerospace engineering graduate from Brunel University, a PhD candidate in fluid mechanics, and the consultant for one of the largest privately developed commercial space launch vehicles in Europe.
So throughout today's presentation, we're going to be trying to cover the full scope or spread of all of robotics and AI that we use and have done at Brunel. We're going to be covering that from the student body side. So Ed and I are going to be taking you through what BRES is as the Robotics Engineering Society, what we do in terms of the projects that we manage, the training that we provide, the industry connections that we've used and built up over the previous years, and some of the external events that we run.
And I will take over and explain you how robotics and AI research has been carried out in Brunel. We'll have a showcase studies and see the potentials of our students on exploring and looking into all these topics.
So before we get stuck into all of that and what we do as a society, we'd just like to take this minute to thank the various sponsors that we have this year, starting from JCR Acoustics, which develop brilliant kits for speakers, Roboton.io that we're using primarily for some of our educational resources. Their virtual software packages are fantastic, and Student Circuit as well, who've helped promote and make this event what it is.
Right, so BRES, the Brunel Robotic Engineering Society. Who are we and what do we do? Well, we are a completely student-led society to encourage STEM-based activities and enhance student skill sets through hands-on learning. Namely, we manage multidisciplinary team projects, so projects that involve not just a particular discipline, but you might be working on projects that involve mechanical engineering, electronics, electrical, aerospace elements as well. We deliver basic training in order to get you up to speed to become involved in more advanced projects, host industry speakers to translate industry experience into your knowledge set, and provide resources and a social space for like-minded hobbyists such as us. We're currently with over 150 registered student members. We have been awarded the Vice Chancellor's Award for Outstanding Contributions to Student Experience, and in fact won the Society of the Year Award for the College of Engineering, Design and Physical Sciences. So some of the projects and benefits from getting involved in this would be the industry style project work. Again, we try to take the knowledge and experience from our industry speakers and translate that into some of the deliverables which we have in our projects. This is a great way to take the theory that you learn inside of the lecture hall and apply that into hands-on practical work. Now, many of you may have already figured out that practical work is nothing like theory, and what you learn inside of the lecture theatre varies quite differently, and is quite vital to know the difference between practical work and the theoretical approach. And finally, it's enhancing the learning experience. There's a lot that you may not completely understand from the theory that's being taught inside of the lecture hall, and trying to learn that and applying that and understanding it through practical work is probably the best approach to solidifying your fundamental knowledge. So some of the projects that we showcase include drones and UAVs. I mean, where would we be without them? The introduction to fixed wing and multi-rotor assembly and flying. So namely taking the aerospace and aerodynamics components and putting them together inside of a mechanical assembly. But we also incorporate a lot of elements from autonomous flight path planning and guidance and navigation control principles. So our current project challenge is to develop a vertical takeoff and landing UAV for autonomous payload delivery. So this involves the challenges of the aerodynamic and mechanical design of the aircraft, as well as the advanced guidance, navigation, and control to deliver the payload accurately and on time. Some of the highlights from past years were developments of autonomous vehicles, which were controlled via computer vision to track and follow colored objects or anything else that can be inferred from a lookup table or library. Moving on to something that goes a little bit higher and a little bit faster, we've got rockets, my personal favorite, as you may have guessed by now. The assembly and launching of subscale rockets. So this is the packaging of the electronics, the propulsion systems, stage separations, and recovery systems. It's also the development of flight control algorithms and approaches. So namely, how to control the launch vehicle on ascent and how to control and recover the launch vehicle again on descent. So this year's project challenge will be to enter the UK National Rocketry Championship for the highest apogee possible, given a number of constraints on the launch vehicle. And the highlights from previous projects were the development of launch vehicles, which had active control and guidance all the way throughout their ascent to the apogee and down to descent with return to launch site capability. Over to you, Ben.
Fantastic, thank you. So as well as the kind of aerospace stuff that we do, we also do some stuff on the land. One of the projects that we run is the electric vehicles, which offers students a brilliant chance to get experience with high voltages and the safety that comes with it, and also very fast spinning things. We also offer this because it offers a kind of electromechanical application that's highly competitive in the racing world. The current challenge that we run for this project is twofold. So we have an entry-level project, which is our kind of go-kart, which is the ambition to retrofit our go-kart chassis with completely electrical components, sensors, and systems for battery management. This then leads student on, or for those that are kind of okay and comfortable with this, to our Formula Student Electric project that we run in collaboration with Brunel Racing, which is to enter a Formula Student Electric vehicle into the upcoming year and develop it completely from scratch. As well as that, we've also opened up a project in medical robotics. This offers students the chance to explore a multitude of various sensor systems, mainly for body tracking and monitoring, and also a chance to start considering robot-to-human interaction, which is obviously vital for medical robotics for a number of reasons. The current challenge that we've set ourselves this year is to develop a medical nurse bot that we hope will assist care workers with kind of tedious or routine tasks that they have to carry out in their day-to-day. The highlights from this project that we saw mostly last year was a brilliant factor and feature that we built was the talking and blinking of the robot, which really helped humans to connect with it, as well as a fantastic follow me service that allowed the robot to follow users and members around, which will assist in a kind of personal or assistive care robot. So as well as the kind of projects that we run in terms of learning new skills and applying them, we also offer a fundamental training aspect. So this is to develop student skills when they're perhaps not so confident in certain areas. And we've broken these down into three main principles. The first being CAD coupled with 3D printing, which is often kind of simultaneous, as well as circuit theory and the practical skills that come with that, that students might need to know if they want to build PCBs, design their own circuits and such. And then we also offer programming training, mostly based around Arduino and basic C++, all the way up to kind of a Python and perhaps a bit of Java as well. Now, we do this in various aspects. We start off the year with boot camp, which is our 3 weeks introduction course covering all of our said 3 principles there. And then we lead this on into a project-based training, which is very similar to the projects that we run initially, the drones, the rockets, electric vehicles and such. But we build a maze solver, so the students take those core principles and they apply them to a project, again, building on what Ed said before, experiencing what it's like in a practical setting. And then finally, we also often have industry-led workshops where we'll invite speakers to come in and lead more comprehensive skill sets.
Fantastic. And taking a page out of industry, one of the biggest and main aspects that BRES would like to deliver to the student body is the Industry Speaker Series. The philosophy behind that is inviting highly experienced members of the industrial community to translate some of the requirements and some of the aspects, be it in practical knowledge, be it in soft skills, and sort of giving the student body a trajectory to follow, a bit of an insight as to what is the main driver for success in the industrial setting. Now, as you can probably see on the screen, we've had a few very, very notable companies being represented at some of our industry speaker series, as well as not indicated with a logo, but we had Dr. David Baker, as a former NASA Apollo engineer, also come in last year, and this was quite exciting. And this is exactly the level we try to strive for, the kind of experience that you want to bring about to the student body, and one of the main ways that we also look to inspire innovation among our peers.
So beyond the kind of projects and the training that we do, we also try and collaborate and work with as many aspects of Brunel and beyond as we can. Throughout our time at Brunel, we've helped assist the STEM team, working with some of the children in various workshops and masterclasses, as well as the Tierney transnational education partnership with one of our partnered universities. We did a week-long maze solving competition, which was fantastic fun. We also partnered up with one of the companies that you will have seen earlier today, the small robot company, on a kind of challenge within the university, challenging other societies to a locomotion competition across a very, very rough terrain. That was an experience. And then PPE manufacturing, we're proud to say that we designated some of our resources to printing PPE for frontline workers during the beginning of the pandemic. We also like to believe that, you know, while we do all these projects, we build up a community. And one fantastic thing we've seen from this is how students go from building kind of friendships to building up knowledge and creativity, and we've seen some fantastic examples here. So this first video shows one of the socials that we had. Right, and from that kind of building up, we saw students also working on some image recognition, which was quite interesting to see, experimenting with TensorFlow here. And then interestingly, some of the students in some free time decided to take apart various components. So this version shows you the students taking apart an RC chassis and fitting it with a new remote control system, an FPV. Finally, this is a couple of our students worked together to build a kind of hack a drone, which was quite interesting to see, applying reading the video feed from the drone and combining this with a new programmed controller.
Wonderful. So if you're interested in getting involved with the Brunel Robotics Engineering Society and any of the activities, industry speaker series, or anything else practical, feel free to get in touch via the links which are available up on the screen right now. We're also available on Instagram, YouTube, and Facebook. Just search up Brunel Robotics. Now, we would like to hand it over to Dr. Tatiana Kalganova to discuss the research being undertaken here at Brunel University. Thank you.
Hello again. I hope you enjoy so far the day. And by now, you're already impressed with work that this brilliant work our students are doing in BRES Society. So they are covering the wide range of the projects. They are doing very high level of wide activities. Basically, our community at Brunel would not be a community at Brunel if we will not cover some activities that has been done by our academics in collaboration with our students and as individual projects. I would like to present you some pieces of work that has been done under Center for AI, Social and Digital Innovation. The unique feature of this center is that it's managed to put under umbrella of the center the academics from different disciplines, from social to engineering backgrounds. As a result, we'll be able to develop technologies, understand the influence of these technologies on society, and adjust this technology, making sure that there are further improvements. Our team is very much experienced, and today you will see only the fraction of the work that has been done, the team that you can trust and work with. I will give you only some small examples of work that our colleagues, academics, are doing while doing research on Frontware. For example, Dr. Mason Abbott has developed a technology that allows to reduce the exhaust emission of NOx and CO2 and soot by 95% for maritime engines. Or Dr. Hongwen Meng, who developed a technology that was bringing the award-winning technology that was providing the motion detection systems at AVIC challenges. Having 15 years experience working in industry, I have learned that developing the research technology is not valid if you will not understand the industrial requirements, and this brings us to development of unique award-winning technologies in Gemstone that later on has been integrated into decision-making process of Caterpillar. We are also champions on affix provenance solution, where we developed the cheaper and smarter solution in comparison with our competitors. This is only a fraction of achievements of our colleagues inside of the centers, but these examples are showing you that we can deliver the impactful research with providing the high performance and quality solutions. Let's have a look what we are doing in our center. Can I just remind you that here we are presenting our work in the area of robotics and AI from engineering sides, because this is how we focus our event here. And we are looking on different variations and applications working in this center, from fusing the data and prediction for volcano eruptions to providing a creative designs using AI in our robotic solutions, for example, for Mona or fire extinguisher. So we are looking on predictions, classification, segmentation, and decision-making algorithms in a number of medical applications, as well as looking on emotion recognition systems. We are also developing some sensors, for example, haptic sensors, providing us some ability to understand and feel the things. Considering that while we are developing and pushing development of new technologies, we are trying to make sure that these technologies can be integratable and applicable in industrial world. We are looking on miniaturizations and scalability of our solutions, making sure that our solutions can work with big data and various environments. Let's have a look on snippet of number of projects that we have. In November 2019, we became a champion in AFEX Microelectronics Supply Chain Provenance Challenge, where we, during the 2 days competition, we needed to extract information from circuit board and generate the provenance solution. Our solution was the cheapest among all our competitors and leading firms in these areas. But also, it was providing some extra abilities, like, for example, creativity of our students led to use of 3D printer for scanning of our devices and providing the high resolution of pictures that we will be later on analyzed for generating the provenance solution. As a part of this challenge, we didn't look only on the static information about the circuits, but also we started to generate the circuits where we looked into the fault detection in the logic circuits. As an example, we developed a fault detection in drone control using AI. And this is one of examples how we are trying to demonstrate our technology for some of the top managers in AFEX. Our 9 years long experience working with caterpillars on generation of roadmaps and evaluation of manufacturing, supply, and transportation optimized networks on Gemstone leads to the fact that is scalable and able to provide solutions in near real time. As a result, we have managed to find the ways how to make such algorithms like ant colonies algorithms and evolutionary strategies become efficient in solution of this this problem. Later on, this technology was providing a number of awards while developing. While we are working with industry, we are developing the new approaches. For example, new Memtic GA for job scheduling, providing 6 times faster solution of global minimum, as well as, for example, in our production of data analysis and modeling, we were able to reduce the rejections by more than 7 times once deployed by the company. Looking on granular computing classifier, we are managing to increase the accuracy by 5 to 20%. We are holding the champion position in case of MNIST classifier as the best performing classifier developed so far. Later on, we started to look into real-time emotion detection and prediction systems, where regardless of how you feel, like sort of smile or very sad or tired or very much excited, this technology will tell us what your emotions are. We have demonstrated these technologies in Deep Learning Summit Londons and in Future of Future Training festivals. This technology has many potentials, from identifications of depressions to creation of new way of storytelling. We are very good in terms of knowledge transfer and looking on adaptations of our technologies and new applications. This is one of the first examples of PowerBrain for base energy simulation and control, where we have all our experience in optimization and decision-making algorithms. We're applying to completely new area, knowing for sure that these will be scalable solutions. Our academics are developing new solutions not only at the level of PhD students and research projects. We work with our undergraduate students and trying to develop their abilities. This is an example of one of the projects that has been completed as a part of final year project for the student, where we worked close with small robot company in creating the intelligent Internet of Things soil monitoring system. The uniqueness of this system is that we not manage to develop devices, but also we develop an intelligent layer in the system, which allows us to collect the sensor data and analyze them. We are using AI in different areas and in different applications. This is a good example how we combine robotics and AI very close together. The uniqueness of this robot hand, not only in the fact that we have, you could hold using right mode the egg and using left hand an egg and right hand the second, but it's also in the fact that everything from routing to controls and adaptation has been done using AI technologies. We use a number of different variations and techniques to ensure that we are providing and creating, designing the most intelligent solution. You could see we have a very wide area of our projects which we have done, and this is only fractions of what we are doing in Brunel. And I would love to show you more. Unfortunately, the time constraint is not allowing. Scientists are scientists, and we love to have a fun. What I would like you to do now, have a look on these 4 pictures. Have a look and try to guess. Is there any pictures here you see at the moment has been generated by AI or not? What do you think? Look at the grounds and guess. Is it top right, top left, top left, bottom right? Have you made your mind? Any ideas? Let's have a look at the answer. Top right picture is done by Madril by Franz Marc, and bottom right is watercolor by Rectopus. Fractal art mathematics generated the picture of bottom left, and the top left picture is made by AI. What is unique features of these pictures, these images, is that this image has been generated 17 years ago in 2003. So we have been doing and experimenting with AI technologies and these applications very long time. We have very lengthy experience of using them. And this is an example of what quality of work we have developed. If you have inspired by our projects or you would like to collaborate with us, please don't hesitate. Send me email, call me, and we'll discuss potentials for collaboration and collaboration methods further.
Welcome back, everybody. Thank you very much for being here. We really hope you've enjoyed today. We're here for our last Q&A session with Ben from BRES and Tatiana on behalf of Brunel. So we've got a couple questions for them. If you've got any questions that you haven't had time to put in the chat, please feel free to do so. So my first question is for Ben, just so we can get him out the way, is obviously you've talked about the BRES projects that you've done in the past and what BRES has been doing. Just as a quick sort of brief and maybe elevator pitch, can you go through what BRES is been like this year and how people can get involved if they still want to in this year right now, going into the rest of the year and moving on forward?
Yeah, no, obviously. So this year's been obviously a massive challenge, I think, for many people as well as certain societies at Brunel. We've tried to do as much virtual planning and training and kind of focusing on those aspects instead of so much what we love to do and the kind of main focus of what we do in a conventional non-COVID year, which is all based on practical work and building. So yeah, this year's taken more of a focus on design and training, and we hope that we'll be able to implement all of that design, practice and training into those core practical skills in the upcoming year. It's never too late to join, as you were just saying. So if anyone is interested in what we do, drones, rockets, autonomous vehicles, or needs some kind of like help with it, then by all means do get in touch with us, and that would be great.
Great, thank you very much. And then Tatiana, I've got a couple questions for you. My first one is, you've got quite a lot of experience in this field. You've been working in design and implementation of applied intelligence systems for 20 years. What has been the biggest differences that you've seen and biggest revolutions you've seen in that time? And how do you think that the year that we've been through this year might affect that?
Being in this industry for so long, yeah, so I can really see the major difference. It's by people's perception and people's acceptance of this technology. If 20 years ago, I will say that I have been doing AI and trying to make any applications and to look into development of some software that could be used in industries and anywhere else, no one will take me seriously. Yeah, I had final year project students who would be working with artificial intelligence, doing projects, and will be telling me, do you realize that once I go to industry, I will not use it? Okay, so surprisingly, once we were going to industry, they were telling me, do you realize I've been using artificial intelligence? But because the public was not ready to accept that we are using artificial intelligence, the techniques and everything, so companies has been forced to don't publicize and let people know about this. There is a major change and revolution came in lately by public accepting artificial intelligence solutions. From the word Google now, it's become norm for everyone, and everyone now knows that AI has been used by Google. Yeah. If 10 years ago I will be asking you to use artificial intelligence in any of the hardwares inside of your home, you'll say, yes, it's very good research projects. Would you use it? And I think this is the major breakthrough. So once people started to accept this technology, there are some other issues which is important to have a look. But this would bring to all development of systems to a completely new level where we can publicly work with companies and technologies and develop this further.
Thank you very much. That's a brilliant insight. And so where do you think that, obviously going in that direction of acceptance and perception, do you think that having a year with COVID where people have been stuck inside, been interacting with people differently, been having to avoid interaction with people, do you think that's going to maybe increase the likelihood of that, increase people's acceptance to stuff like that? What's your take?
Being lost in virtual world is it's becoming a norm, but the humans are humans. Like sort of, you started to a lot of people started to appreciate the benefits artificial intelligence, robotics brings into your everyday home. So a lot of you already have many devices, artificial intelligence being integrated at homes, and you look this as a norm. Yeah, but the human interactions nobody has cancelled. Okay, yeah. So even though that you will be trying to work remotely, and thanks to a lot of digital technologies, digital innovations, AIs, and so on, yeah, so you will see that we have get these lockdowns more comfortably if, for example, we'll remove these technologies. People started to accept more of these technologies. But regardless of what we have with technology, it helps us to do some particular tasks, make some decision making, and make some impactful progression, but it doesn't mean it will replace the human interaction.
Very, very, very fascinating stuff. We've got a question for seemingly Ben in the chat saying, could you give some examples on how you've been able to cope with your PhD as well as working with the BRES projects?
Yeah, so obviously both quite challenging, especially when chairing a number of our projects. But it's all about time management and delegation, as you understand, Ryan, delegating the tasks out to some of the committee and allowing them to do their own thing. But yeah, I'd say, admittedly, it's been a struggle. Coupling it with my research has been quite handy. There have been times when I've needed to use some of the BRES tools, facilities, lab access, and resources that we generally have, and it's been quite beneficial in my PhD, especially in the practical lab experience.
Fantastic. We've got one more question for Tatiana. One of the previous presentations, it was mentioned that AI deep learning is more than a good pattern, more a good pattern than actually learning as humans do, and that can be limited. Could you give your opinion on that?
Yes, if you will start to have a look on any algorithmic developments of AI, and at the moment AI is more resonance with deep learning rather than with anything else. And don't forget that any AI, it's simple algorithms. Every single algorithm has advantages and disadvantages. They have been developed for particular reasons, and they perform the best for particular reasons. If you're going to try to apply the same algorithms for something that we are not developed for, you won't be able to find appropriate solutions and structures. And it's exactly the same with deep learning. Deep learning could be good for some tasks. It not necessarily will be perfect for everything. Solutions. Nowadays, surprisingly, we see a lot of people trying to use deep learning for all possible tasks without evaluating what will be the best approach to them.
Got a couple more questions coming into the chat, but unfortunately, we're getting to the end of our time. I think Ben has some closing words he wants to say. I'd like to just say thank you very much, everyone, for coming and for listening to my voice all day. I'd like to thank Tatiana, Ben, and Ed for speaking, although Ed couldn't be here.
So thank you very much, Tatiana, for speaking and saying that. Ryan, thank you very much for the questions and managing all of that. I'd like to close the whole thing. Welcome. Thank you for coming, essentially. I'd like to thank our sponsors who've helped support this event, Roboton, JCR Acoustics, and Student Circuit. I'd like to thank everyone who has viewed today or attended at some point. And mostly I'd like to thank our companies for just attending and putting on fantastic presentations. We've seen some really, really exciting stuff, and we hope to continue this and see where these companies go. Also behind the scenes, I'd like to thank our producer, Niall Williams, who's managed all the editing, and Ryan Took for answering all the questions and just generally managing all of the speakers. Finally, if you do want to get in touch, you've found anything here interesting or exciting, and you'd like to ask us any questions about what we do, collaborate with us, or generally find out more about what we can offer, then please do get in touch. Our contact details will be either in the presentation or on the Brunel Robotics website. And also, just I think a little question there, student-wise, if you do want to ask questions about BRES in particular, please contact us there. Anyway, I hope you've enjoyed the diverse experience and understood that robotics and AI has a huge scope. Thank you very much.